Hey everyone, welcome back. In this video, we are continuing on with our review of the squeeze theorem. We are covering the second most common type of problem that you may see on your AP calculus exam. Okay, so please take a second to pause this video and read through the question. I am not going to read it aloud, and then meet me back here for the problem solve. Okay, so this question, we are using the squeeze theorem to try to find the limit as x approaches 0. First things first, of course, we have to understand the squeeze theorem. So basically what we are doing is it is a technique for finding the limit of a difficult function by squeezing it in between two outer functions. So you can kind of see here in all of our answer choices, right? In this case, we're squeezing f, in this case, we're squeezing g, and in this case, we are squeezing h. So what has to happen is that our outer functions, say here and here, the limit of those have to equal the same as our inner function. So immediately looking at my answer choice, I don't like 1 because these two sides aren't off by a negative sign. I'm definitely skipping steps when I say that. I'm just giving you the fastest kind of like shortcutted way to solve that. So immediately this is a red flag for me. Why? The longer way of doing this is because if I took the limit of this and I took the limit of that as x approaches 0, they would not equal, right? But my brain is just kind of conditioned to look for something like this, where my outer functions are the same and they're just off by a negative sign. So that's kind of me shortcutting it. Okay, so I'm going to eliminate number 1 because again, the limit of the left and the limit of the right side functions, they are not equal as x approaches 0. So let's go ahead and eliminate that. I know 2 must work because my only 2 answer choices have 2 in it, so I'm going to assume this works. And then let's go on to number 3. Okay, so here I do like that these are the same and they're off by a negative. However, if I were actually to take the limit of the left side and the limit of the right side as x approaches 0, I would get undefined, and I need those functions to be defined. I can't use the squeeze theorem if the limit of my 2 outer functions are undefined. So unfortunately, I have to eliminate answer choice 3 as well. I don't know why I said unfortunately. It's not really unfortunate. I'm just saying I have to eliminate answer choice 3. So let's go ahead and eliminate D, and the correct answer would be B. Okay, moving on. Same thing here. Go ahead and pause this video and read through the question if you'd like. I'm going to jump right into the problem solve. All right, looking through my answer choices, same issue here with option number 1. I don't like this one because this and this are not the same or off by a negative. So I could just mentally quickly check it. If I took the limit of this side as x approaches 0, I would not get the same as 1/2. So this would not work. Let's go ahead and eliminate that. So anything with 1, I'm going to eliminate. Moving on, 2 must be correct because B and D both have 2 in there. And then number 3, I have the same issue I did in the last problem. The problem with this is if I took the limit as x approaches 0, it would be undefined. And these 2 outer functions have to be defined, right? Because I have to be able to conclude the limit of the inner function. So I'm going to go ahead and say 3 does not work either, and I'm going to eliminate D. And once again, the correct answer would be answer choice B. All right, hopefully that made sense. If not, leave me a comment in the comments below, and I'd be happy to answer any further questions. I'll see you in the next video.